Sixth sum, very very important sum. You need to understand properly, otherwise you can't able to derive this sum. So listen carefully. Assume a rate at which radioactive nuclei decay is proportional number of such nuclei present in the given sample. This is nothing but decay sum. Therefore it is reduces slow by slow it is going to be reducing. So how are we going to write? Let A be the first let A be the radioactive substance at time t. First we will put a tabular column, next I will do the sum. So listen. In a certain sample, 10% of original number of radioactive nuclei have undergone disintegration after a period of 100 years. So what is given? Read it once again. In a certain sample of 10%. So they given a certain sample. So that is some already present, that is some initially present bracket is present. So I am going to take time t, I am going to take amount as A. Amount is A. Initially I am present, I am going to keep radioactive substance A0 radioactive substance. Initially how many radioactive substance present? A0 radioactive substance is present. If I going to present some amount only, it will slowly disintegrates. Otherwise this will not disintegrate. Disintegrate is nothing but it is making reducing down. Radioactive nuclei decay means slowly reducing the amount we have kept. If we are going to keep 10 kilo of radioactive nuclei, after 50 years it is going to be a 5 kilo. Slowly reducing. After slowly this amount will be reduced. If you are going to keep camphor also, if you are going to keep camphor, it is slowly reduces amount. If you are going to keep 10 gram of camphor in sunlight or outside at room temperature, it will slowly reduce to 5 gram after 10 days. So this is called decay. So first if I want to make a decay, first I need to present some amount initially. This amount initially present, A0 is the initially amount of radioactive presence. See, in a certain sample of 10% of original number of radioactive nuclei undergo disintegration after 100 years, 10% of A0 is reduces. 10% of A0 is nothing but what is given? 10% nothing but 10% of A0 is reduces. Sorry. 10% of A0 is reduces. If 10% of A0 is reduces, after 100 years, how many A0 is present? 90% of A0 is present. Listen very carefully. So if I am going to place A0 amount. After 100 years, 10% of A0 is reduced. So after 100 years, how many percent of A0 is present? 90% of A0 is present. Because 10% A0 is vanishes, it moves. So after 100 years, how many A0 is present? 90% of A0. So this one 90% A0, I can write as 90 by 100 of A0. No, so we put A0. 0 cancel. So by 9 by 10 A0. So at 0 years, initially A0 is present. After 100 years, 9 by 10 A0 is present, because 10% of A0 is reduces. So 9 by 10 A0 is present. So what is the question? What percentage of original radioactive nuclei after 100 years? They are asking for 100 years. What is the percentage? They are asking percentage too. They are asking percentage also. So we need to keep this sum very carefully. We need to find percentage of A0. Okay. How we know the sum? So dA by dt is directly proportional to A. We will put tabular column, then only it looks good. Okay. Therefore dA by dt is equal to Ka. K is a proportionally constant. dt moves here, S comes down. dA by A is equal to K into dt. Integrating on both sides. Integration of dA by A is equal to K into integration of dt. Log A is equal to Kt plus log C. Log C, that is log A by C is equal to Kt. Therefore A by C is equal to e power Kt. A is equal to C e power Kt is the first equation. Keep it as first equation. After writing this, case 1, case 2, case 3. Apply case 1. What is case 1? T is equal to 0, A is equal to A0. T is equal to 0, A is equal to apply. What is A here? A naught. A naught is equal to C e power k. What is T here? 0. A naught is equal to C e power 0, which gives us C is equal to A naught. So apply C here. Apply C in equation 1. So A is equal to C is nothing but A naught e power kt. Keep it as equation 2. This is the main equation. Case 2 and case 3 should be applied here only. What is the case 2? Case 2 is nothing but T is equal to 100, A is equal to 9 by 10 A naught. We need to apply in 2. Apply in 2. What is A? 2 is nothing but A is equal to A naught e power kt. This is equation 2. What is A? A is nothing but 9 by 10 A naught is equal to A naught, right, is A naught e power k. What is a T here? 100. T is nothing but 100. So what are you going to do? Some see here, A naught cancel, e power 100 k is equal to 9 by 10. E power 100 k is equal to 9 by 10. Next, case 3. Case 3 is T is equal to 1000. I need to find percentage of A naught. Apply in 2. Apply in 2. Apply. What is A? I need to find. Okay. A naught, right, is A naught. E power k. What is a T here? 1000. E power 1000. So we can write A naught e power k. This 1000 I can write as 100 into 10. So A naught e power 100k. This 10 I can write as whole power 10. A naught e power 100k. E power 100k is nothing but 9 by 10 whole power 10. A is equal to A naught 9 power 10, 10 power 10. So they are asking A in percentage. So A is equal to A naught 9 power 10, 10 power 10 percentage multiply by 100 and put it percentage here. So this totally how many zeros present here? 10 zeros. Here 2 zeros. 2 zeros and 2 zeros we can cancel. So it becomes A naught 9 power 10, 10 power 8 percentage. You can able to understand, I think so. How? Because here how many zeros present here? 10 zeros present here. Here 2 zeros present here. Here 10 zeros, here 2 zeros. We are going to cancel. Still there is 8 zeros. No, I can put 8. So how we can take it? This is the answer for this. How we can take and write this answer for this? See, 9 power 10, 10 power 8% of radioactive element will remain after 1000 years. We need to put A naught. Percentage of radioactive element will remain after 1000 years. Thank you.